The figure on the board shows 4-bit synchronous binary counter. This counter is implemented with negative edge triggered JK flip-flops. We were supposed to draw the timing diagram for this particular synchronous counter. From where we're supposed to start? First, we're supposed to realize that anytime you will connect the counter to the power, we are going to have always initial condition on the outputs. Outputs, I mean Qs. Q0, Q1, Q2 and Q3. We have 4 outputs of the JK flip-flops. We are going to assume that we are going to start from state 0, binary 0, 4-bit number. The very first step, anytime you will analyze synchronous binary counters or decade counters, you're supposed to first set the modes of each flip-flop. In order to set the mode to each flip-flop, you're supposed to remember the truth table of the JK flip-flop or any other flip-flop which you are going to analyze. In this case, we are going to talk about JK. Remember that anytime J and K are going to receive zeros, you are going to set the flip-flop to no change or hold mode. Anytime you are going to apply 0 to J and 1 to K, you are going to set flip-flop to reset mode. Means Q is going to be always 0 after each clock pulse. If you are going to have 1 sent to J and 0 to K, you are going to set your flip-flop to set mode. Means anytime you are going to trigger the flip-flop, your output is going to be always 1. If you are going to apply 1 to J and 1 to K input, you are going to set your flip-flop to the toggle mode. It means that anytime flip-flop is going to receive the clock pulse, is going to change its state on the output from 0 to 1 or from 1 to 0. Toggle means constantly changing. Let's take a look at our counter. First flip-flop, flip-flop 0, is connected by J and K inputs to high. It means that J is receiving high and K is receiving high. We said that anytime J and K, both of them are highs, we are going to set this particular flip-flop to the toggle mode. So I'm going to write T, and this T stands for the toggle mode. This flip-flop is going to toggle when clock pulse is going to come. Next, Q0 has 0 because we assume that our initial state is 0. This 0 will go to these inputs. Both of them are what? 0 and 0. Anytime JK flip-flop is going to receive 0 and 0 to JK inputs, this flip-flop is going to be set to the hold mode. I'm going to just put letter H, which is going to represent hold mode. Means no change. Next, Q0 and Q1, Q0 and Q1, both of them are connected to the AND gate. This AND gate is going to receive 0 from Q0 and is going to receive 0 from Q1. Anytime AND gate is receiving 2 zeros, output is going to be also 0. This 0 is going to go to JK inputs. Again, I'm going to have 0 over here and 0 over here. We said already that anytime J and K are going to receive zeros, the flip-flop is going to be set to the hold mode. Next, output of my gate G1 is connected to the input of gate G2, which is simply 0 and 0. Both zeros are going to give me 0 on the output. This 0 will go to, again, JK inputs. We said anytime J and K are receiving zeros, the flip-flop is going to be set to the hold mode. Next, we have to apply the clock pulse. We said that these flip-flops are triggered by falling edge, negative edge triggering, right? So when the falling edge is coming through the input, the flip-flop is going to be activated. So we said the very first flip-flop is going to toggle. So if we had 0, my output right now is going to be 1. We said that after clock pulse, this flip-flop is going to hold. Means if I had 0, my output after clock pulse is going to be 0. Why? Because I have to hold. After clock pulse, my second flip-flop is going to also hold. So if I had 0, I'm going to have also 0. And my third flip-flop also is going to hold, because if I have 0, I'm going to have 0. Why? Because JKs are zeros. JKs are zeros. JKs are zeros. And we have JKs 1, 1. That's why this one had to toggle. If you want to implement these conditions on the timing diagram, remember we start from 0. So this is my 0. This is my very first state. Binary 0. Right? And my next state is nothing else, just binary 1. Remember that this flip-flop, and particularly this Q output, is going to represent my least significant bit, where the very last Q is going to represent my most significant bit. So after clock pulse, we said that my Q0 is going to be switched to 1, when rest of my flip-flops are going to remain the same states. In other words, I have 0, 0, 0, 0, 1, 0, 0, 0. Next, this time we said that Q0 has state 1. Now this one will go to both inputs J and K, so both of them are going to receive highs. And we said that anytime JK flip-flop is receiving highs on JK inputs, the flip-flop is going to toggle. So that's why I'm going to write letter T for toggling. Output Q0 is also connected with the AND gate, to input AND gate, and this very first input is going to receive also high. Q1 is connected also to the gate and is going to send 0 to it. 1 and 0 for AND gate will give me 0. This 0 will go to both JK inputs, and we have 0, 0. These two zeros are going to set my flip-flop to the hold mode. This 0 will go to another AND gate, and Q2 is going to also send 0 to my gate G2. 0 and 0 gives me 0, and this 0 will go to my JK inputs, and JK's zeros are going to give me hold mode. So that's why I'm going to write H. When we finished with the modes for each single flip-flop, we can apply the clock pulse. So if I'm going to apply the clock pulse, remember that this clock pulse